All right. Now, the next component in our roadmap is coordinate systems. So, a coordinate system or coordinate reference system or CRS defines how coordinates map to real places. On the other hand, a projection is a slightly different. The Earth is curved, but most of the maps that we use and screens that we use are flat. So a projection is the mathematical transformation that flattens the Earth onto a 2D plane. So the important part is that every projection makes trade-offs. So some preserve shape, some preserve area, some preserve distance locally, but no flat map can preserve everything perfectly. So that is why the correct coordinate system depends on the task or the project. A web map, a global dataset, and a survey-grade engineering design may all need different coordinate systems. Usually in major projects where the scope of the project is big, you would work with multiple coordinate system, and at some point you have to convert them to a single coordinate system. So one of the coordinate systems is called EPSG 4326, also known as WGS 84. This is the coordinate system most people use at first, or most people encounter at first. So this is the standard used by GPS and many location APIs. So coordinates are expressed as latitude and longitude in degrees. For example, a coordinate such as negative 122.42 and 37.77 refers to longitude and latitude. So the coordinate system is excellent for storing global locations and exchanging data between systems, but it is not ideal for measuring distance or area directly because degrees are angular units, not meters. So WGS 84 is great for location, but for measurement, we often need a projected coordinate system. EPSG 3857. It is a web Mercator. This is the coordinate system used by most web maps, including Google Maps, OpenStreetMap, Mapbox, and many other online mapping platforms. The reason is um, this is very popular because it works very well for fast map rendering and also for tile systems. But scientifically, it has distortion. So areas become exaggerated as we move toward the poles. So Greenland looks much larger than it really is compared to countries near the equator. So Web Mercator is excellent for visualization, but we should be very careful using it for analytical, um, especially if we have some area calculation in our analytics. The next item in our coordinate system is UTM. So UTM is commonly used in engineering, surveying, and local analysis. And in UTM, we have multiple zones. For example, we have UTM zone 17, which using WGS 84, uh, basic WGS 84 is the datum of that uh, zone, and the coordinates are in meters, which makes distances and area calculations much more meaningful within that zone. And the key idea is that UTM divides the world into multiple zones, and within a zone, distortion is controlled and measurements are more accurate. So if you're doing engineering work, infrastructure analysis, or local planning, a suitable projected coordinate system such as UTM is often much better than raw latitude and longitude. And we always have to check coordinate systems before doing our analysis.